is a demonstration of the Caffe environment build and source code compilation. The first step is to install CUDA and CUDN. Firstly, we need to find the directory where the CUDA installation package is located. Keep pressing the space key and finally accept the terms. Please do not install the graphic drivers you have installed before. Press Enter key to confirm the installation path, and you need to enter the password with administrator privilege. Press Y or N to install symbolic link or not. It is optional to install CUDA samples. Press Enter key to confirm the installation path. CUDA installation is completed. Next, it's time to install CUDN, and the following commands can be found in MDK menu. Here is the sub-link creating. Then we need to set environment variables. Create a link file. Add the following line to the file. Save it and input the command to make the link effective. The following step is testing CUDA samples. We use make command and there are errors because the GCC version is too new. The solution is written very clearly in the manual. Then we make it again. There's no error. Enter the following commands in the terminal. When this screen page appears, CUDA is installed successfully. Then we install dependencies. Those commands can be found from menu. The next step is merging MDK and Caffe source code. The specific operations are searching the keyword GTI with Ctrl F and copy this content to the corresponding part of Caffe source code. This part is a little bit mechanization. We can fast forward on it. The following is to replace a part of Caffe source code files. The specific steps are in the ready-made file. Under Caffe's installation directory of MDK, fast forward again here. The Caffe source code can be compiled after this part is completed. We need to modify contents of the make file first. Uncomment this line. Add a path after this line. Save exist. Type make clean first, then type make all to compile. Python environment variables need to be set after type Caffe. And I have set in advance. And then import Caffe in Python. If there's no error, it indicates that the installation is successful. This video provides a brief introduction of the practice of target detection. The main difference is in the process of data preparation in object detection tasks. Take the object detection as an example. The first method is that you can download the VLC dataset from the internet and convert it into the LMDB format. A URL is provided here. You may read according to your own needs. The second method is to annotate your own dataset. There are lots of annotation software on the internet, for example, label image. This is a download link. The training process is the same. The first step is to train a complete floating point model. It may be easier to convert with a pre-trained model weights. The second step is to fine-tune the quantized convolutional layer. The third step is to fine-tune the quantized active layer. And the fourth step is to further fine-tune the generated model. If the model needs to be loaded into the MPU chip, the model should be converted. The following is the result of the demonstration. This video uses image classification as an example to introduce our Caffe MZK training process. The first step is to train a floating point model, which is correctly points path to the location of the dataset. Here, change the output into 6, means 6 classes. And set a net to the path of floating model we just modified. Notice that the path should be written here, not only the file name. Now execute the following commands in terminal. It is the second step of training process, fine-tune the quantized convolutional layer. You need to copy the prototype file of the floating model we just trained. Change the first 7 layers of convolutional to 3 bits and the last 6 layers to 1 bit. Here, still change the net in solver file into network model we just modified. And then execute the following commands in the terminal. Remember that the weights refer to the model we generated in the previous step. The following is the third step of training model. Fine-tune quantized active layer. First, we find the Python file to modify the prototypes and Caffe model. A new proto-text and Caffe model will be generated after changing. Then we need to train the model with the generated proto-text and Caffe. The following is the final step of the training model. Fine-tune the model. Firstly, we need to modify proto-text and the Caffe model in the program. And then train the model with generated proto-text and Caffe model. The learning rate is changeable according to the actual situation. Normally, the learning rate can be 0.1 times in this progress. The operation here is to generate a new proto-text by combining the proto-text generated in the first step with the deployed proto-text. So for details, please refer to the user manual. Then we find a file under the conversion to change the output of FC8 and submit to 6, which is our classification number. And then create a VGG folder in the conversion to a directory. Copy the new proto-text and the Caffe model generated in the first step and label txt into this folder. Next is change the access permissions to the entire folder. Then execute the convert file and check the passing parameters. And you can see an output folder with the model files.